All right, today we're starting periodic trends. We have three trends we're going to go over. The first is atomic radius, second one is ionization energy, and the third is electronegativity. So atomic radius is just merely the distance from the nucleus to the outermost energy level. So what it does is it basically measures the size of an atom. So within a group, the atomic radius will increase as you move down a group. So you can kind of see that here. So as you move down the group, as you move down group 1, you can see the radius getting bigger. And why is this the case? Well, there's two major reasons. First is you have a new energy level. But the second one is that the inner energy levels shield the positive attraction and the positive attraction of the nucleus. So remember, what's holding together these atoms is the positively charged nucleus in the middle, and then the negative electrons that are outside, right? And so that attraction between the positive and negative is what's holding it together. So just to give you an example, lithium has 3 protons. It looks like this. Sodium has 11 protons. But if you look at the periodic table, sodium has 3 energy levels. And just by looking at your Bohr model, you can kind of tell sodium will be bigger. It has an extra energy level, and what happens is remember, what's holding this electron is that there's an attraction between this electron and those 11 protons. However, if you have more energy levels in between, so you can see there's more energy levels in between the outer energy level or the valence energy level, they kind of shield that charge, that positive charge. Here you can see that there's only one energy level shielding between the outer energy level and the proton. All right, but what about you have the same number of shells or energy levels, but what happens along a period where they have the same number of energy levels? What happens to the size of an atom? So across the period, the atomic radius decreases as you move across the period. Why is this the case? Well, the number of energy levels stays the same, but as you move across, what happens is the atomic number increases, so therefore there are more protons. Therefore, there's more positive charge or more nuclear charge, which is holding on to those electrons more tightly. And so then the radius decreases, so you can kind of see here as you go across. As you go across this way, you can see that the radius is decreasing. Why? They have the same number of energy levels, right? Because of the same period, but what happens is the number of protons increases, so there's more attraction, and so those attractions hold on to the electron more tightly, and that makes the atom smaller. So, for example, lithium has 3 protons. Looks like this. Beryllium has 4 protons. And so what you see is those 4 protons have a greater pull than the 3 protons. And so beryllium should be smaller. And I'm drawing arrows showing that what happens is those energy levels get more and more kind of compressed or pulled in, and so it's smaller. So therefore beryllium has a smaller atomic radius. Okay, now everything we do now is based off of atomic radius. So everything I do or talk about will be related to atomic radius. So ionization energy. Ionization energy is the energy required to remove an electron from an atom. Okay? So immediately we can think, if you have a small atom, it's going to be harder to require more energy to remove that electron, right? So if you have an atom, let's say this is a proton, and this is the electron you're trying to remove. Well, if it's closer to the positive charge, it's going to be more attracted and held more tightly, right? And so it's going to be harder to remove. Whereas if you have a larger atom, and it's way out here and you're trying to remove it, well, it's going to be easier to remove. Why? Because it's not held as tightly, right? Because of the shielding, it's further away. And so there's not as great of an attraction between that positive and negative charge. So it's all based off of radius. The first ionization energy is energy required to move the mostly loosely held electron. So the valence electron, one of the valence electrons is the first ionization energy. So there's a second ionization energy, third ionization energy. Okay, that's what it says there. So ionization and atomic radius. So what I want you to see is it's easier to remove electrons farther away from the nucleus, from the positive charge. So ionization energy and atomic radius is opposite, right? The bigger the atomic radius, the easier, the lower the ionization energy. So if you go down a group, the radius increases. So as you go down a group, the radius increases, right? And so therefore the ionization energy decreases. Across a period, it increases, and so the amount of energy it requires increases, or the radius decreases, so the ionization energy increases. All right, electronegativity. So electronegativity is, I'm going to give you a definition. It's the ability of an atom to take control over the bonding electron. So it's the ability of basically of the nucleus of the positive charge to control its valence electrons. So here we have a kid who's farther away. A kid who is farther away, it's harder to control versus a kid that's closer. So electronegativity also has to do with atomic radius. So it's easier to control if it's smaller, right? If it's closer to the nucleus, or kind of like the parent, if the kid is closer to the parent, or the electron is closer to the nucleus, you're going to have a high electronegativity. They're going to have a high amount of control, right? But if the kid is further away from the parent, I should have drawn this opposite, actually. This would have a low electronegativity. Okay? So I think we do the same thing. So it's easier to take away electrons from elements that have large atomic radius. So as you go down a group, the radius increases, so the electronegativity decreases, right? So the atom's bigger, so they have less control over the valence electrons. As you travel across the period, the atomic radius decreases, so the electronegativity increases. Here's homework.